Up next, we're talking area models. This is one of my favorite visualizations for multiplication of both multi-digit numbers and later on in algebra of binomials. So this is something that is well worth paying attention to, and it is going to be very different from anything that anyone my age or older learned when we were in school. But it is absolutely worth getting to know and understand these area models because they will make more complicated ideas later much easier to swallow, okay? So multiply 2 digits by 1 digit with area models. Let's take a look. So what an area model is we are acknowledging that 71 is 7 plus 1. Right? 71 is 7 plus 1. And we've talked before, we did it a lot in 3rd grade, about how multiplication and finding the area of a rectangle are not just similar, but they are the same thing. Finding the rectangle's area and multiplying the numbers together are identical. They are mathematically equivalent. So when we go to multiply two numbers, we can make a rectangle that is 71 length and 6 width, or vice versa, doesn't matter which, and we can use that visualization to help us. And if you look at this, we are splitting this 71 up into 70 and 1. Well, 6 times 70 is 420. No comments, please. And 6 times 1 is 6. I hope that makes sense. It's the same thing that we were talking about before, where you break the number up into smaller pieces, do the multiplication separately, and then recombine them. So I got the area of A was 420. And the area of B was 6. So the total area, 6 times 71, is 426. Nice. Same deal, except now we're doing 37 times 7. And again, it's just a matter of finding the area of each of these two rectangles and then adding them together. It's a visual device to help people see what's called the distributive property of multiplication, which we have also talked about on this channel at great length. 9 times 30 is 270. And 9 times 7 is 63. So all I have to do now is add those up. 27, 28, 29, 30, 31, 32, 33. I got 333 as my answer. 27, 28, 29, 30, 31, 32, 33. Yeah, that's right. Now, I'm actually going to pause and expressly ask if anybody has any questions about this particular model, because it's one that I learned as a teacher and not as a student. And whether you find it useful for you in particular or not, I would know if anybody has any questions on how this works or why it's useful. Same deal here. And I'm actually going to go ahead and draw on the diagram this time. This green rectangle here is area 4 times 60, which is 240. Because this is a rectangle, this rectangle B also has a height of 4, right? That stays all the way across, assuming it's a rectangle. 4 times 2 is 8. So the area of the purple rectangle is 8. The total area is 248. 62 times 4 is 248. Let's go back over there. 248. And again, It works for some people, it doesn't work for other people, but whether or not this is your go-to method, you still should understand it because it's going to make some things a lot easier later on, promise. So once again, we have 2 times 50 to get this green rectangle, that's 100. And we have 2 times 7 is 14 for rectangle B, I guess we could call it. So 57 times 2 is 114. And again, you should be able, I mean, not you should be able to, but I can more or less quickly in my head, like confirm that that's true because this is how I would do that multiplication in the first place. If I was going to do 57 times 2, I wouldn't visualize rectangles, but I would say, oh yeah, 50 times 2 is 100, 7 times 2 is 14, I would add them together. This is what I do in my head. It's just adding the visual of the rectangles. Which I appreciate. A lot of folks are very visual learners, and this sort of thing can help them.